All right, the Hangout is on air live. Okay, group meeting quiz. Basically a review of 15. Everybody feel pretty comfortable and ready to take the exam?
Yeah.
Sure.
I gotta slow down this next time and read the questions clear and make sure I'm clear on everything.
Right. All right. So, number 2 on the quiz, is that where we're at?
Number 1.
True.
Okay.
Here's the
So
answer.
question 2. So are these in different orders to the ones on the...
The questions are in the same order, it looks like, but the answers are mixed up. So we've got to make sure that we're correct on those.
Okay.
Right.
Okay, cool.
So
question 2, I had the second one.
Yep. Second one, right.
Is that right? We are 90% confident that the true mean heart rate is between?
Yeah.
Okay.
Yep, that's what I had.
Okay.
Number 3.
Question 3. The researchers decided. I had, yes, the distribution of the mean of each sample is normal since the data have been determined to be normal.
Yep, that's the same one I picked.
Yeah.
All right, question 4.
Now, question, yeah, this is the one I battled with.
Okay, so of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? And I chose confidence interval for the mean of differences using dependent samples.
I chose difference of means using independent samples.
Independent? Okay, let's figure out why we chose independent or dependent.
And I didn't choose either one. I left it blank. So I can't even be the tiebreaker.
Well, the original question says the researchers decided to construct a confidence interval to determine if the difference of the means is significant. That's probably why I picked the one that said the difference of the means.
Well, they're doing, the researchers randomly selected 20 females and 15 males. So the question, they wanted to determine whether the reaction time in seconds to go, no-go stimulus of males differed from that of females. So if you're first doing males, you had to do females. So I thought it was dependent.
No, because you can't figure out which females are used based on which males. So that'd be independent.
So it's independent then, you're right. Because it's dependent if it's like the before and after. That's okay, now I get the question.
Or if the females were the husbands or the wives of the males, then we could do it that way. But the females weren't related to the males at all.
Yep.
All right, so independent.
That's right. Yeah. Okay, now I understand that question.
All right, question 5.
Now it's interesting because I got a different answer to the, so I don't know if my Excel's messed. I got a slightly different answer to the, what was offered there.
You did?
Yeah, on the homework. So.
For question 4?
No, it's not question 4.
Oh, for question 5.
Yeah, question 5, yeah, that's right. Sorry. So this one would be if you increase the number, isn't it? The 4th one.
Question 5, a researcher is interested in estimating the savings account. I had obtained a balance of 90.
Yeah, I put 90 customers instead of...
Yeah.
That's what I picked.
The balances of
the last one.
The more
you
have,
all right,
we'll narrow that margin.
Yeah. Okay, so 6.
Margin of error. Let's see. 3 notes. Determine the margin of error. Do you have that?
Oh, wait a minute. This is different.
No, you don't get to select on this one. You have to write it. So it's 99,996.080. Is that right?
Well, that's the lower bound, right?
Is it asking for the
It's asking for the margin of error, so we're going to have to subtract and divide by 2.
Hold on. Let me see. So the confidence intervals are 1001.960, 98.04. So take 1001 minus the 998. So hold on.
You're breaking up quite a bit, eh? Unless it's just me.
The headphones, my mic on it is stacky.
I have 3.92.
Margin of error. I have 1.96. You have to divide it by 2.
Divide it by 2. What are you using for your lower and upper bound? I think we're using different numbers.
My upper was, I got A on the homework.
I got B on the
1001 point.
I got B on the homework.
Yeah.
You did?
Although when I worked it out, my number was slightly different. So like in the homework, it had 996.080. I got 996.818. That's why I was wanting to check what you guys got.
Then you used the wrong one. Yeah, it has to be exact.
No, I get that, but I thought it was the closest one.
It's a lot. That's closer to B than A, though.
Yeah. Okay, let's do this quickly again then.
I use that one rule, the 98, 95, 99.7 rule. And if we're gonna do it with a 95% confidence interval, then that would be 2 standard deviations away from the mean, which would be 99.6 and 1003 or 1004.
Oh wait. No, we're getting a 95% confidence interval.
Right.
Which is a 1.96.
So,
or the Z factor, or your Z is 1.96.
Yeah. So I had X as 1,000, Z as 1.96, the popular standard deviation is 2, and the sample is 4.
Yep, and I got 1001.960, and
that's 998.04.
Yep.
So what you got?
Yep.
I got as well.
And so when I minus the A, 1001.960 minus 998.040, and then divide it by 2, I get 1.96.
Maybe do that. Yeah, 1.96. That doesn't seem right though. So that's the same number as Z.
Yeah, but you're just looking for the margin of error with all those things. I think you did it on purpose to make you a question.
See, if I worked out the margin of error the other way, I get 0.0098.
But you always take, what do you mean, 0.0?
Oh no, that's, yeah.
Yeah, because you're first we're solving for the confidence interval. And no matter what, it's always the upper minus the lower. And if you got 1001.96 and I got that, then you take that minus the top one and then divide it by 2.
Okay, but look, if the mean is 1,000, then 2 standard deviations away from 1,000 is going to be 996, not 998. And we have to go 2 standard deviations away if we want to.
Brandon, your Z-score is 1.96. So if you open up the app and you click in the middle and then you put in 0.95, your Z-score is a 1.96.
Yep.
For a 95%.
Okay, so
on that app,
that Z-score 1.96 times the standard deviation, which is 2, is almost 4, which is a lot closer to 996 than 998.
No, with the sample number of 4, it ends up being the A one.
Huge. Okay.
your standard deviation of 2, and then your number of 4.
What does the number have to do with it? What equations are you guys using?
So my formula for the margin of error is times, open brackets, the popular standard deviation divided by the square root of n.
No, margin of error is your confidence, your upper confidence level minus your lower confidence level divided by 2.
Okay.
That's your margin of error.
But the confidence interval is calculated by 1.96 standard deviations from the mean.
Or confidence levels are worked out by, there's two formulas. It's your standard means minus your critical value, which is your 1.96, times by your
Standard
deviation divided by your square root of n. Let me just check something. I want to check my notes on margin of error.
This is the one that I missed and ended up, I've gotten it right every time since then.
Let's see.
To figure out your confidence interval,
I am getting 998.1040 now that I'm using that equation, but it doesn't, not making sense.
Yeah. I have an Excel. I did an Excel thing.
Yeah, I
so
did too.
just input stuff.
Okay, let's go with 1.96 then.
All right. Okay, so what is the answer we got for 6?
1.96.
1.96. Okay.
Okay, so the lower bound, 998.040.
Does it say how it ran to 3? Okay, I have to change that. Yep.
Right.
Okay.
Does it say round to
998. Yeah, 998.040.
Good thing you caught that.
And then your upper
Oh,
bound.
yeah, it'll still be 998.0.
Yeah, upper bound is 1001.960. Okay, we're a third of the way almost. Oh, no, we're not. Okay.
Okay, so 9. To assess the laboratory scale. Let's see.
So I got 38. Yeah, I did this one. I think, is this the one where it's 38,416?
That's what I got.
Yep. But is that what we're looking for in this one? Confidence zero.
Yeah.
How large should n be? So that 95. Just asking.
Yeah, it's the same question. How large?
Oh, it's a
Yeah.
margin. No, it has a margin.
Sample, is it margin error or sample size?
Oh, no. How large should n be?
Yeah, so the sample size.
38,416.
38,416, yeah.
Okay, question 10. I had.
This one's going to be 4, isn't it?
Yep, the fourth one.
Yep. Third of the way, boys.
Oh, you had Brandon?
Yeah, that's what I got.
P is less
It's
than.
still mixed up by 7 being 10, 8 being 11.
Yeah, I know. It's
Oh, I
That's
know.
in my head.
so 11 is where P is less than sigma. Eh?
Yep. P is less than 8. Yep.
8,
Or alpha.
The p-value is less than, yeah. All right, yeah. 12.
Around 12.
So this one
It is enough.
got.
Let's.
What did I write here? Yes.
I think I put the third one in this.
Yes, that's what I put because of the bell-shaped one. Right. I think it was more of a guess.
Well, all three of us came up with it, so I think we're good.
Must be
Okay. Okay, was this a committed type 1 error?
I have a, yeah, committed
That's what I
type 1 error. That's what I put.
Okay.
Yep. 14. Let's say.
I have the first one for 14.
Oh, did you? I had the fourth one, but I need to figure out why.
Yeah, I had the first one. So reducing the
You got
population.
first?
Yeah, but I'm trying to reread the question now. If the level
Okay, if the level of significance.
Whenever you make the level of significance smaller, you reduce the probability of committing a type 1 and increase the probability of committing a type 2.
Type 2.
So if you make type 1 small, you make type 2, you increase
Bigger.
the probability of making type 2. So I thought it would be D.
Oh, it's D in the
That would be-
homework, I think, but it's the first one on the quiz.
Oh, I'm sorry. I was looking at my homework.
Yeah, I'm like reading D. I'm like thinking, huh?
Oh my goodness. Yep. Okay. Yeah. I was looking at my homework that I had the fourth one there. So yeah, we're good.
Okay.
Like you said, it's confusing.
Yes, it's messing me up for sure. All right, the next
Okay,
one is,
nicotine content.
this is the nicotine one.
Nicotine content. Yeah.
I have failed to reject.
I put we reject the null.
I had failed to reject. I have to go back and work it out.
Let me look at the question again.
Okay, let's see.
The nicotine.
Was 12. Oh, I think I put failed to reject because the margin of error is 0.033. When I worked it out, that gave enough to, it was like right on the border.
Well, the nicotine and cigarette contain a certain brand. Okay, I want to rework this out quickly.
Okay.
I hate this having to rechange all my forms. I should have just taken screenshots.
I know, right?
I did on some of mine and put it on there, so I understood why.
The sample was 100, do I remember, hey?
Yep, the random sample of 100. And the sample mean was 1.53.
Yeah.
That's what it was. The mean nicotine content is 1.5. And so the sample mean was 1.53. And then I came up after the confidence levels with a margin of error of 0.033, which was enough to make it bigger, p-value bigger. Because I think the p-value was like right on the border.
Well, the p-value...
I have 0.040 for the p-value.
What was it?
0.040?
Yeah. It was, I think I had, was it 0.040 or a little above 0.
I mean, just above 0.040, but if you round it, it's 0.040. So that's That means we reject the null because the odds of getting these results are so small.
Yeah, the p-value is 0.
0.04.
.040 is the p-value. Are you putting in the null hypothesis of 1.5?
No. I missed that. Oh, and it's greater than, not less than. So my p-value is 0.04.
Yeah.
So it means p is greater. I mean, sigma is greater. The p is less.
Yeah. Yeah, the p is low, so we reject the null, which would be the fourth option on the quiz.
Yep.
All right, we're gonna go with that. All right, reject the null. Okay, question 16. You would like to look at the mean number. A dependent samples test or matched pairs test. Oh, it doesn't give that.
So
But there's no
what is the
relation
trick?
between the male students and the female
Oh,
students.
paired sample test. Oh, there it
Yeah,
is.
so it's
Paired sample
independent.
test.
Yeah.
It would be independent sample t-test.
Correct.
Independent again because you're
Or is
dependent. You're choosing females because of the males.
No,
Maybe I'm
the
getting this
females
up on
have nothing to do with which males were chosen.
No, it's that you did males. Now because, well, random sample.
There's no way to find out which female students were chosen based on knowing which male students were chosen.
Okay, so it's independent because of that.
Yeah, but hold on.
Okay.
Is this not a one sample t-test? Because they're not asking between the two. They're just saying the number of hours per week, male and female students. Oh, they are group and test if those two means a difference. Okay, never mind. So it's independent sample t-test.
Yeah.
Okay.
Okay.
Educator is interested. I've got dependent sampling, or am I wrong?
This one is dependent.
Brother and sister pair, so that is dependent, correct?
Yeah, correct.
If you select a brother so as to compare his academic achievement to his sister.
It's the last one, eh?
Yep. Yeah.
Yep.
Number 4.
Okay, soil science.
No, we have to.
Confidence interval for U or mean when sigma is unknown.
Yeah, that's what I have. Which is the first one in both cases.
Yeah. Did you get that, Peter?
Yeah.
You're on 18.
A. Yeah, I'm just trying to see which one's A on 18.
It's the first one in the homework and the quiz.
Okay. I didn't even read the first one because I didn't think it'd be the first one. I'm like, it's on there. Oh, man. I hope I read on my exam properly.
This is probably
which is the following is 95% confidence level. Put your answer.
Oh, we're gonna have to put it all.
Dang it. I have to work this out.
Yep.
interval for this data. Determine margin of error. That's easy. It's just.
Oh, I have this in. I put this in.
2.7 minus 21.96.
What did they want? Determine the margin of error. Oh.
2.024.
Did you use a one sample t-test? I've stuffed this up because I can't even put my rails in there. Okay. So just load it all again.
It's for the lower bound.
Standard deviation. N was 20, eh?
Yeah.
Are you using the one sample t-test for this?
I am.
I believe I did.
I don't know if that's right. I have 0.034
For what?
for 19. Or did we do that one already?
No, we didn't do one.
What'd you get?
0.034.
Hold on. What were your upper bound and lower bound?
My upper bound was 1.564 and the lower was 1.496.
Wait, how can you? I had 11.168.
For one of the confidence intervals, or for the difference, or I mean for the
Yeah, for the confidence intervals, I had 11.168 for the lower and 15.217. Let me see what I used for the scientists. Simplest field measure to tell the point. This is just the very first one.
What did you guys get for the lower number? 11.297.
Yeah.
And the
yeah,
top
I
one
think
for-
I think I need to reopen this quantitative inference procedures thing. I think I did the same mistake I did before and typed something in where I shouldn't have. Oh wait, 11.168.
Yep.
Okay, yeah, I did. I had too much information punched in from one of the questions before.
Okay, so if you take the lower and the upper, or the upper and minus the lower, and then divide it by 2, I got 2.024
No.
margin of error.
No, I got 1.895. What was your lower number?
11.168.
Oh, no, I have 11.297.
What do you have, Brandon?
11.168.
Okay, I'll go with you guys. So there's something wrong with my document then.
Did you choose the correct? Or
Well, did you do rounding of your? So which sheet did you use?
Yeah,
Did you use
3
the?
decimals.
Which one did you use? The quantitative.
The one sample test.
Yeah, see, mine stuffed my one sample. Where did you download that from again? Because I'm using 2 different documents. I'm using.
Okay, yeah, I used the one sample t-test. I put in all the variables. And then I did a not equal to.
Yeah,
But
I
that,
did less
that didn't
than.
affect anything, but I still ended up with 15.217 and 11.168.
Yeah, I've got that now that I use that. My variable section of that doesn't work, so I'm having to use the quantitative descriptive statistics and copy all the values in.
Ooh.
Yeah. No. So that quantitative one gives me different. Anyway, okay, so let's go back to this quiz here. So the margin of error for this is that minus that divided by 2. Minus that.
Okay, for the margin of error, I got 2.025 instead of 2.024.
Well, you got to remember it's 2.0245. So that 45, that 5 should round that 4 up to a 5 because it's below the 5, shouldn't it? Oh, maybe. See?
I always thought you rounded it like everything else.
Isn't margin of error rounded up?
4, 5. Yeah, I guess if the 5, it would round it up to a point or the.
Okay, so we have to round to 3 decimal places.
All right, so you guys, I would round the 4 up to a 5, so 2.025.
Yeah, that's what I have. That's what I'm just doing. Yeah.
Say it again. What did you guys get?
2.025.
0.25. Yep, got that.
How about that?
Okay.
The lower bound was 11.168, right?
Yeah.
Yep.
68, and then the upper bound was
15.217.
okay.
Hmm.
All right, next.
Now you got to use hammers.
Random sample of Hummers for sale. I got confidence interval for the mean of differences using dependent samples.
I got the opposite one. We got the difference of means using independent samples.
Okay, so I've been messing up on that all night, so I'm going to trust you. But I thought they.
Yeah, because those numbers in
This
those
is
numbers in
independent.
New York are unrelated.
Okay.
Are we on?
I'm not
Hold on, guys.
understanding that.
What question are we on?
22.
Okay.
Of the 4 types of
22 on the
confidence
quiz.
intervals listed below. And on the exam, that is question 17.
It's 3, isn't it? Independent samples.
Yep, that's what Brandon got.
Oh, okay.
Yeah.
And so
I just thought you guys were working it out.
you're helping me understand the difference between dependent and independent, so that's good.
Oh, now I've got to put it back in my document to make sure it's right.
Okay, calculate the 95% confidence interval. I got lower bound minus 423, or negative 423.
That's what I got too.
Okay, and for the upper bound, 5417.
5417, yeah. I hope these are right.
So which sheet did you use for this? Did you use the paired samples or the 2 sample test?
I used the
I don't remember what I
two-sample
did.
t-test. I believe I used,
Which one?
yeah, the 2-sample t-test.
The 2 sample.
Yep.
Okay. I just want to double check my work here because I'm starting to think I made a mess. I can just open the right document.
Ooh. On the group meeting quiz, does it say on those? Hold on. Round to 3 decimal places. So we got to put the full decimal places, Brandon.
Oh,
Yeah.
heck. So it's negative
Minus
423.238.
Yep. Whew.
I'm so glad you saw that.
Yep.
And then 5417.336.
B6. Yeah, he's tricky.
Yeah. So it's minus 423.238.
Correct.
Okay. Yeah, it works out now. That's 5. 417.336. The next 4 questions.
All right. So on this next one with the exercise bone density, I use the ANOVA analysis of variance.
Yes.
Yeah, because it has multiple variables.
Yeah.
Has the control. Just going to reload it all back in quickly. I need to seriously re-download all of these documents again because I think I've made a mess of a couple of the formulas. So what did you get for the test statistics? 7.978.
Yes.
.26 done. And the p-value is 0.002.
That's what I
Correct.
have, yeah.
Okay. Okay. Now this is the one I get messed up. There is sufficient evidence or there's insufficient evidence.
Okay, so your
So we failed.
002.
So we failed to reject. Is that right?
Mm-hmm. So what do you find on that?
No, we rejected the null.
Number 3.
No,
We
that,
didn't
yeah, we
fail to
rejected
reject
the
it.
null.
Oh,
Yeah, we rejected the null because
We
it's
rejected
p-value
it.
low.
Yeah,
So the null says everything's equal.
okay.
So if we're rejecting the fact that everything's equal, then what do we determine?
we know that at least one of the groups is different. So it would be there's sufficient evidence to conclude that the bone density of at least one of the groups is different.
Okay, 3, sorry.
That's correct.
Yeah.
I'm going to battle with that one on the exam. Oh, come on,
All
seriously.
right, so this one,
My machine's doing a Brandon today.
What's that?
My machine's acting like yours today.
Oh, yeah. Man, I could
this one on
not
the
get
homework.
to work 2 days ago. It was crazy. All right, so is it the
So did
fifth
you
one?
use it? What did you use? What did you use a two sample mean test?
For number
I
2?
use, for the next one,
Yeah.
I use the paired sample t-test for means.
Okay, the one with the differences.
Dependent samples test or matched pairs test.
Yeah, dependence.
And did you,
What I have.
did you exclude all the ones with a 0 on the other side? Or did you include them?
Hmm?
I thought it excluded itself.
Yeah, it excludes itself. You just got to put it in.
Oh, does it exclude itself?
Yeah.
Yep.
I cut and paste it individually.
So,
Seriously, it excludes itself.
yep.
Yeah.
Because there's nothing to compare it against. So it gets no
I don't believe
value.
you.
It only takes the ones that it has
Oh.
values for. Okay, test statistic.
I can't believe that.
5?
Say again?
685. Yeah, that's what I
Yeah,
have.
1.685. I can't believe it. But you know,
we got to send out a text or something.
yeah, but you know what's different here now is if your first one is 303.69, it doesn't have a variable. If you delete that, it changes the mean. It changes the mean on variable 1's line, and the number counts. So it doesn't change anything on the paired sample. Okay. So we don't exclude them. Is that what you're saying? Because I've been excluding them. Okay.
And my numbers show the same, 88 and 88.
Okay.
By putting them all in there.
Okay. That's weird. P-test means.
Now the last one, did you get your p-value? 0.096?
Which we use dependent sample test, on this one, on 29.
Yes.
Okay. And the t-test 1.685, I think everyone got.
Yeah.
Yep.
Okay. P-value. Now this is interesting because we round it to 3 decimals, so it's 0.096. Is that right?
Right.
Correct. Yep.
0.096. Oh, not 8696.
Now this is what I'm curious to see what Brandon got on this. So I put, there is insufficient evidence to conclude that there is a difference in the cost of tickets purchased 14 days in advance compared to 90 days in advance.
No, we're going to reject the null because it was lower than 10%.
Yeah,
and this is the I was talking about, those real close, because it's 0.0956 or it's 0.096. And then
yeah, it just
margin
barely makes.
Yeah, and I thought with the margin of error, it would push you more to choose there is insufficient. But do you think just because it's, even though it's just a hair below, you still would reject it?
Yep.
Yep.
Okay. So let me see. There is sufficient evidence to believe that there is no difference in the cost of tickets.
Yep, number 4.
Okay.
Oh no, number 3. Sorry, number 3.
Okay. Do you want me to go first?
Is it number? It's number 3. Hey guys.
No, wait. Isn't it number 2?
There is sufficient evidence to conclude that there is a difference in the mean. Nope.
Because the null was there's no difference in the mean, but we're rejecting the null, so there is a difference in the mean.
Oh.
So that means
See, that's where
you were right.
Insufficient. Okay, so it's the second one?
Yeah.
There is sufficient evidence to conclude that there is a difference in the mean.
Yeah.
Hold on.
That's looking for a 0.9, or yeah, 0.90 or 0.9 confidence interval, or significance.
All right.
0.10.
I'll turn mine in.
You gonna turn it in, or do you want me to?
I'll turn it in.
Okay.
Let's see here. Crossing my fingers.
I think we got 28. No, that's too many. We must get 30 at least. 2 wrong or 3 wrong.
Good, 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 good,
Scroll
good,
to the bottom.
good, 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 good. Wow, good, good, good. We're amazing. Good, good, good.
Scroll to the bottom and just put us out of our misery.
Good, 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 good. 100%.
Oh, wow.
Brandon.
Nice.
Oh, that's fantastic.
I'm glad you understand some of those things better than me.
Yeah, and vice versa, for sure.
Let's see. 30 out of 30, huh? That's impressive.
Hopefully, we do this well on the test.
Okay, I believe I understand that there's between independent and dependent now.
All right. Well, another thing that I haven't read anything about the project that we have coming up, so I don't know anything about it, but except that we're probably going to do some kind of study like we've been doing all along here, right?
Oh, we have to pick a study, I think.
Yeah, we have to
anyone have
decide
something in mind?
I thought about doing something like the weight of a small McDonald's French fry or something to see how they vary, because we've got 3 of us in different areas.
Oh, that's perfect.
McDonald's.
Because you can get a lot of fries for cheap. So that would be perfect.
Yeah. That's why I figured if we did the small, but we each have to have a way to weigh them.
We have to have a what? Say it again.
A scale to weigh them.
I have a small digital scale that's just perfect for the job.
Yeah, and I've got one at work that I could use.
Yeah, I've got one in our office.
All right.
We're gonna have to pretend we're using the same scale though for all three.
Are we gonna use one fry, or are we gonna use a packet of large fry? Okay. No, but I mean I suppose that gives it.
I would do all small because they're cheaper.
Oh no, I'm not worried about the thing. I'm just worried about, do we do it the whole packet and say this is how many you get of a small packet, or do we take every fry out and weigh it individually?
No, all the fries together to see what the variance is.
So we'll have 3 samples, is what you're saying?
Mm-hmm.
Or are we going to weigh each individual fry and have 100 fries each?
No. It would be we do so we wouldn't have the population mean, because we don't know what unless we call what was it? I think McDonald's, if you look on there, they say how much it weighs. We compare that as the population mean, and then we take each of our samples.
I bet we can find that information
on
McDonald's website. Yeah. But we're going to need more than 3 samples, though. So shouldn't we weigh the fries individually?
Oh, no. I was thinking, like if you were to buy 10 packs, and I were to buy 10, and then.
Yeah. So why don't we do this? Why don't we buy 10 packs of the individually small ones and weigh those? And we can say in a small packet of fries.
Okay. My kids are going to love this study.
And I was thinking, I mean, it would almost go with I don't know if it would go for an ANOVA, because if we're looking at a McDonald's in McCalla, Alabama versus a McDonald's where Peter lives and where you live.
I think it would be ANOVA. It's 3 different sample groups, right?
Yeah.
Yeah, we're trying to do it of the US, and so we're taking 3 individual. So, well, yeah. We'll just say we can do it different.
Yeah, we'd have to use the QQ plots for each of our things, because it's a small number, a small amount, if we're only doing 10 samples each.
So how do we know what the average weight is of a small one?
I think I looked it up. It was like 0.6 grams or 6 grams or something like that, or 6 ounces, or I can't remember. We'd have to decide that. Or we don't use a population mean, and we just use our sample means.
Oh, yeah.
Yeah, we could do that. I'm going to quickly Google it and see.
Okay. And then we're basically just comparing our McDonald's equals in their divvy up of small fries. First within our own little group, and then compared to the whole.
Okay, so let's get this right. So what we're going to do is we're all going to buy 10 packets of small McDonald's fries and weigh that whole packet, not individual fries, but the whole small.
Yeah, but you have to dump the fries out of the
packet. Yeah, I get it. But we're not doing individual samples. We're doing individual small packs.
Yep.
Okay, cool.
All right, cool. And then we can work out the details of how we worked out the numbers later. But we know what we're doing now. We're buying 10 packs of small fries. Okay.
Yep. So now we have to come up with our design the study.
Well, that'll be next week or the week after, right? As long as we know what we're doing for now, I think we're good.
Yep.
Don't mix don't in my head until I take the test.
Okay, so the small fries, 80 grams.
All right.
I just found it online.
Yeah, you got to make sure that you have that's what they have listed for them?
Yeah, 80 grams.
Okay.
80 grams for small, 114 for medium, and 150 for large.
Good deal. So we just have to be able to weigh in grams when we do it.
Yep.
Sounds good.
Well, we can always convert. Okay, cheers, guys.
All right.
All right, cheers.
Good luck.